Well, good afternoon, everyone, and welcome to Taco Tuesday. Today's topic is all about split case pumps, and we're going to, Brett Zerba in a few minutes is going to go into a deep dive about split case pumps. My name is Rich Medeiros, and I'm one of the senior systems engineers here at Taco. And I thought I'd just go through a couple of quick items, introduction first, and then some housekeeping things. Again, welcome to Taco Tuesday. Taco has been in business just over 100 years. We actually celebrated our 100th year anniversary last year during the middle of COVID. So we are in the process of continuing that sort of 1 year celebration, a year late. Little company history. The company is, as you can see on the screen here, was founded in 1920 by the White family, and it's currently operated by John Hazen White Jr., who is the third generation. And the fourth generation is currently working at Taco. That includes Ben and John the third. And we have some great news. The fourth generation. Is it the fourth generation, Brett? Do I have that right?
Fifth,
Fourth generation
the
is
fifth, the fifth, the fifth.
the fifth. Oh, sorry, that's right. Third, fourth. That's right. This is the fifth generation. Oh my God. Um, so yes, the fifth generation has arrived, and it's Madison and Winona. Um, so we have new additions to the company. Whoops, sorry about that. I meant to shut off my phone. I apologize. Couple of things. In a minute, Brett's going to start the presentation, but before we do that, I'd like to talk a little bit about some housekeeping things. We have some handouts, 4 handouts that you can download as PDF files, which you should be able to access from your control panel. Just to make sure that everyone can hear us and see us okay, if you could just click on, let me make sure I got attendees. Yeah. If you could just click on the hand wave, and that'll tell us that you can hear us and see us okay. I see a couple of hand waves. Yep. So that looks like we're broadcasting. Very good. Thanks for doing that. So if you have some questions, please type them in. I will be acting as the moderator today, and I will try to answer your questions in real time. We'll actually ask Brett to pause periodically so that we can read your questions and we can answer them while the presentation is going on. If we don't get to all your questions, we will get to them. We can answer them in an email format. We will be recording today's session, and you'll be able to access that recording roughly 24 hours from now, so roughly noontime tomorrow, East Coast time. You should be able to download the recording. And also, if you're interested in getting a certificate for the course, there will be an email available probably again around 24 hours tomorrow afternoon, and you'll be able to download the certificate for the course. So I've gone through the intro, a little company history, handouts, how to ask questions. We did the hand waving, email, and recording and email for the certificates. Brett, did I miss anything? Is there anything else I need to add before I turn it over to you?
I think you covered everything, my friend. Great
Okay.
job, as usual.
All right, so in a few seconds, I'm going to turn it over to Brett. Just a quick intro for myself. Again, Rich Medeiros, mechanical engineer. Been in the business several years. I am a PE, and I specialize in the engineering and design of HVAC systems. And then I'm going to turn it over to Brett. He's going to introduce himself and then start the presentation. Brett, take it away.
Thanks, Rich. Appreciate all that info. Hi, everybody. My name is Brett Zerba. I'm an applications engineer with Taco. I am a degreed mechanical engineer. I graduated from the University of New Hampshire in 1981. Wow, that's a long time ago. A little story about my morning here. I'm actually on a business trip to the lovely city of Buffalo, New York. So in order to make sure I got here and without having the bottom line is I had a 5:30 a.m. flight out of Boston, Massachusetts this morning, so I could get here in time to get in front of you folks and talk about split case pumps. So If I'm a little discombobulated, I did have a couple cups of coffee, so I think I'm back to normal here. So we shall see. We shall see. Although normal is really a strange
Yeah,
statement for
and
me.
Brett sent me a text message this morning at 4 a.m. to let me know he was traveling.
Well, the crazy, there's two parts to that story. He received it and responded at 4 a.m. So
Yeah, I know it.
you got you got a couple of nuts talking to you today. But if many of you, I'm sure, have sat in on some of these in the past, so maybe you already realize that. But it is, I know Rich has been on a couple of business trips in the past few weeks, months, and this is probably my second. So we are starting to get back out there. So
Yeah, I was just going to use the same words. We're getting back out there, Brett.
yeah, it's if you have some wants and you want to see us in person, get in touch with your Takeo rep, and I'm sure we can set something up.
We should have like a a brochure signing. We should like have people come over and we'll sign brochures and
There you go. I like
yeah,
that idea.
I
I
know
like that idea.
it'd be like book signing.
There you go. So today's topic is split case double suction pumps. It's something Taco's been manufacturing or in supplying to the industry for many, many years. And obviously, we're not the only ones that do that. So let's get into it. There are other. Ours are green. We like that color. We like that color. So hopefully you like that color too. And I'm sure many of you have seen red ones or blue ones on job sites as well. But nonetheless, we do manufacture them as well. So here's what I'm going to talk about today. And really, these are our models over here that we have, the TAs, the GTs. And I'm going to get into the details of this, of all of these. It's going to get a little mundane and dry, but maybe some of this stuff that towards the end might liven things up. And I got some cutaways and some different stuff, but really, I just want to explain what these are and go from there. Actually, I think one thing Rich and I have learned. Whoa, shoot! I hit the wrong button. Not unusual for me. Sorry about that. One thing Rich and I have learned with some of these webinars that we've been doing for the last year and a half, year and 3/4. We get to get in front of you folks a little bit is to define what we're talking about, right? Sometimes we jump right into it because we assume things and we really shouldn't. And maybe of the 100 people on here, maybe 90 of you know that, but maybe some of you don't. So what is a horizontal split case pump? They're different than our base mounted pumps that we've talked about in the past, or the vertical inlines or the inline pumps that you folks may be a little more familiar with. But it's still a type of centrifugal pump used in the HVAC hydronic industry. It may have some other uses in some other industries too, or the model type, not Taco's type, but you may see them maybe in fire pumps or something like that. But what defines it is the casing is split into separate chambers, and you'll see what into two chambers, and you'll see what I mean by that when I get into some of the pictures and some of the cutaways very shortly. I'll try to make sure we all understand that. So it is different from an end suction pump. Those base mounted, the Taco FI pumps or CI, but the FI is on a base, as well as our KV and KS pumps. In which the suction nozzle and discharge nozzle on those pumps are all included in one chamber. And hopefully you can sort of understand that, and maybe once I show you some pictures, you'll understand that even more. So when this casing that we're talking about is split along the horizontal plane, it is now known as a horizontal split case. What a surprise, right? I hope all that makes logical sense. And obviously, when it's split on the vertical plane, is known as a vertical split case. Pretty straightforward there in that regard, I hope. Here's the first one I want to talk about is our TA double suction series pump. And so let's kind of look at, let me get my little doodad here. Here's what I'm talking about with the casing, right? This is the casing. This is the wet end, the casing, whatever you want to call it. So it's split along this horizontal axis right here, right? You wouldn't see that in an FI pump. You would not see that in an FI pump. So the water comes in over here, right? Rotates around. And we're going to talk about rotation on these pumps because it's very, very critical for you folks. I tell you, when I get to that screen, I am going to emphasize that. If you take away one thing from today's webinar, please take that statement away once I get to that screen. But so a couple of the thought processes on these pumps, and they've been around for a long, long time. And very rugged, heavy-duty casing, right? And because of its make and thickness, it does allow for probably more higher water pressures, and so that's something to think about. And I mean, us manufacturers, and you'll read it all over, we say the top half of the casing is easily removed. That's kind of an oxymoron because think about it. Anything that weighs 200, 300 pounds is never easily removed, in my opinion, right? Especially in a mechanical room, as you can only imagine. But as you can see here, there's probably 20 some nuts and bolts here you got to undo. And then if you have the right equipment, you can lift this up, and then you have access to the chambers inside and the impeller and a lot of other of the components in there as well. And because of the impeller design, it's double suction. And I'll explain what I mean by that when I get into some more pictures. The MPSH on these, in most cases, is probably a little easier to design around than some of the base-mounted pumps. So something to consider there as well. And then because of that double suction into the impeller, the radial thrust, axial thrust, I should say, is quite reduced. So the longevity of some of the bearings and whatnot should be a lot longer than the base mounted. And a good friend of mine, Chris Wilson, told me way back, right, that these were the ones in our industry that were specified on a daily basis, and they still are by some engineers. But us pump manufacturers have made our end suction pumps, the RFI, and then obviously you have other models out there. I'm not even going to mention them for other manufacturers. Have improved those base mounted pumps to the point where there really isn't that much bearing life difference in the two models anymore. So you know, there's not really a reason not to specify the base mounted specifically just from longevity or from that standpoint. Hopefully you kind of understand that. I'll talk about why some people might specify these, and usually it's flow rates or maybe some space considerations or whatnot. Even this base, similar to the FI base, should be grouted, right? Some of our bigger ones, the base is a lot more rugged because so it may not need to be grouted, but the TAs, it still says in the instruction sheets, and you'll see that if you download one of our instruction sheets, that it still should be grouted. Here's some of the performance data. And if you think back to the FIs, I think the FIs max out around 4,000 GPM, maybe a little more, a little less, whatever. The KV and KSs go up a lot higher than what you're seeing here. So there's a big overlap, and that's not unusual in the HVAC pump industry. So really it becomes down to a lot of personal choice of which ones you want to select. And that's really your decision. The team, you know, in the most cases, my recommendation would be the team's decision. There's probably a price difference. If you think about what a base mount, you know, an end suction pump looks like compared to this, I think most of us can realize that there's more money. Us manufacturers have to spend more money to assemble these, make these, put these together. So you can see that there is a price difference for most applications. But you know, once you get up to a higher flow rate, you may want to start thinking about these as well. And you can see these temperature ranges are pretty high, and that working pressure, right? That working pressure gets up there pretty high as well. And you know, we have all different sizes. You know, some of the small ones. If some of you have been to our new mechanical room, we have some on display there. I think they're on the heating, one side of the heating loop for the building or whatnot. We wanted to make sure we showed all of them, but nonetheless, they are available, and you can kind of see some of the, some of the data associated with that right here. Here's when we talk about deep dive, I want to make sure everyone understands these three slides are going to be you're going to see them. There might be a little subtle differences for all of the models I'm going to talk about, but it's just important to know the different material of construction. In the standard, as you can see there, is pretty similar to the end suction base mounted pumps. For the most part, even the vertical inlines, cast iron, bronze, right? The shaft sleeves, all pretty common stuff there. And you can see that operating specifications. They do come with a seal flush line, a recirculation flush line. So that's very important. You got to be careful when you're handling those. So nonetheless, they do come. And it's a standard type of motor, T or TS frame. You can get a lot more information if you go to the motor folks on that. TS is just probably for the bigger ones. They just change that designation. So it's really a pretty standard, I'm going to say off the shelf motor, but once you start getting up to 300 horse or 200 or 150 or whatever, I don't think anything's off the shelf in that regard, especially in this time that we're talking about now. But and there's some options there if you want this seal flushing, right? We have a recirc flush line. The filter and abrasive separators is something to consider thinking about specifying. That there are some engineering firms that have it written into their specs, and what those do is they really help clean the water to extend the life of seals on HVAC hydronic pumps, and it could be any of them, any type of model. It's something to think about. We've talked about those in the past. They are available out there. And they are options for us, and any of our manufacturers reps can get you a lot more information on those. Matter of fact, I think on one of our previous webinars, I actually had some attachments that gave you more information. It's the same type of setup as those, but in this day and age, it's very difficult, especially for pump manufacturers and even you folks as engineers. Water quality, right? Water quality is a big issue out there, so that's something to consider as you start thinking about specifying these pumps down the road. So here's a cutaway of a double suction, horizontal double suction pump. Okay, so when we talk about the water, these are the chambers here. These are the chambers. There's that flush line I talked about, and I got a couple other sketches that'll show you even more call out of different components and whatnot. So the suction and discharge is down below here, but you can see this the water goes into both sides of the impeller, right? So as long as we'll talk about the piping and the flow rates and all of that to make sure that we understand that as well. But as long as that's equal and coming in there properly, you're going to have very little axial thrust. So you can kind of see that. And again, I know a couple of you may remember these impellers throw water, right? They have curvature space. Veins in there. They don't suck. I shouldn't say suck. Scoop water. They throw it, right? So you can tell that with the way the rotation is on this here. So that's kind of a pretty good idea of what the cutaway is, and some things here. You got some wear rings that are pretty common in there, and different types of materials for some of the components as well. But you get a good idea of what's inside one of those as you start going. So just think about trying to take this cut. Well, this is a half cover, right? It's a cutaway, but trying to take this off to access all of this stuff. Obviously, in most of these pumps, you're going to need some type of overhead crane or a fork truck to lift things. So it's yes, it's easy, but it's not easy if you know what I mean. And this is the screen. The statements to the right is what hopefully, if you're going to take away anything from today's presentation, you remember this, and trust me, it happens, and it's unfortunate when it does happen, but it's critical. It's imperative that when you order these pumps, or these pumps are specified, and I don't care if it's green, red, or blue, whatever color it is, you've got to order it with the correct rotation, clockwise or counterclockwise, and that's from sitting on the coupling end or sitting on the motor. So sit yourself on the motor, look at the pump installed in your mechanical room, and make sure you order it clockwise or counterclockwise. They can be changed in the field, but it's a PIA. Okay, it's a big PIA. Trust me on that. You got to replace the gasket and flip things around. You got to. It's not an easy setup to do. So if you think about it, right, this shaft right here that has the bearings on it in the motor, you have to rotate everything there because now it has to rotate in the other direction, and this shaft have to come out this side. It's really, really a pain in the neck. Just keep that in mind. You got to take things off. There's instructions on how to do it, but like I said, and this is common for any one of the models I'm going to talk about today. You have to make sure you order them correctly. I think on our ordering format, are you sure? Are you sure you want to delete that? Are you sure you're ordering it correctly? And it's very, very important. And you can see what I'm talking about, the rotation here, right? So the suction comes in, right, horizontally, comes in at the same level, right, kind of same level right here. It comes in, and there's that rotation. So I'm sitting on this motor looking at this, and hopefully everyone realizes that's clockwise rotation, right? Clockwise. Well, nowadays, not everybody knows what a clock is with a actual second hand that's rotating. We all have our phones. Let's see, my cell phone doesn't tell me doesn't show me a rotation, but hopefully I'm kind of goofing around there, but I think everybody understands that. And excuse me, obviously over here, depends on the mechanical room, depends on the piping, right? And the layout, this is counterclockwise rotation. I think it's pretty straightforward. But nonetheless, so, if that thing gets switched around during design, make sure somebody takes that into account and gets back to the pump, to the manufacturer's rep, pump supplier or whatever, so that can be taken into account. Obviously, if we have to change it, it's easier. It's a heck of a lot easier if we do it at our facility, so just keep that in mind. It's under controlled circumstances. Otherwise, it can get out of hand. And think about it. Based on some piping arrangements, you may have one the same pump, the same model, and you may have a clockwise rotation and a counterclockwise rotation on the same order. So don't hit quantity 2 with these pumps here if you have 2 of the same on a project, unless you make sure you're very, very comfortable with that. Rich, how are we doing for questions? Anything yet, or is
Actually, I was just going to say, why don't we pause for one quick second? If you folks have any questions out there, now's a great time to type them in, and we'd be happy to answer the questions for you. I don't have any questions active right now, Brett. So why don't you continue, and I'll continue to monitor. And if there is a question, I'll ask you to pause for a second.
Rich, do you have any experience with these type of pumps and the incorrect rotation ordering in your illustrious career?
Yeah, we actually had one several years ago that was ordered, with one, I believe it was ordered as a clockwise rotation, and what they really wanted was a counterclockwise rotation. So so they had to change the configuration of the pump in the field. So it's pretty much, just a lot of labor, but it can be done in the field, but it's labor intensive.
Yeah, and field labor is not good labor when you're doing stuff like that.
So we did have a question: are these types of pumps quieter? And the question was asked by Gordon. So Gordon, could you add a little more information? Are you saying quieter compared to, for example, an end suction pump or a vertical inline? I guess that's really where you're sort of headed with your question.
It's one of those questions that has a lot of answers, but let me just say, and maybe Rich can add to it. If the inline pump, or these pumps are installed correctly, piped up correctly, grouted correctly, aligned correctly, both of them should be very, very quiet and within a couple of decibels of each other. You know, if one has if they both have 100 horsepower motors, you shouldn't hear any of them except, you know, just the normal noise that a piece of equipment like that makes. But it's really a lot based on the installation, and we're going to talk about some of that down the road. Anything you might want to add to that statement, Rich?
Yeah, the only other thing is that generally speaking, and this is sort of generic of all rotating equipment, the slower they rotate, the less noise they generate.
Good point. Good point. So, you know, under normal circumstances, we offer them at nominal 1200, 1800, and 3600. So, you know, I think most applications are at 18 or 1760, but the slower the better. So, and the
Yeah, so
quieter.
when I mean there's always a trade-off because let's say you had two options, you could go with a 1760 or an 1150 RPM. 1150 is going to be quieter, but it's going to be physically larger in order to accommodate the same flow and head. So yeah.
Great question. But you know, the design team uh, really has to think whether they want to use these. Once you start getting up higher, but now you get these vertical inlines that could probably go up as almost as high as these two, but some people want the base mounted. So anyways, let's look at the GT double suction. And this is kind of a higher version of the TAs. When I say higher, higher flow rates, the TAs went up to what, 5,000, 5,500, something like that. These bad boys go up quite a high, much more higher than that. And I'll get to the performance as you look at the next screen. Excuse me. Pretty much the same, right? They look very, very similar, very similar. Cast iron again. I mean, HVAC hydronic pumps virtually are all cast iron, and I shouldn't say all, right? That word is gets you into trouble. But nonetheless, 80, 90% of them are cast iron for most manufacturers, almost all manufacturers. But there's that split case again, right? You can see that right here. It cuts away across here. You got that rotation issue again. These bases, although if you go to HI or if you go to ASHRAE, they may recommend any base in this industry should be grouted. These bases are meet requirements that they don't require grouting. So the heavier the duty, the higher end the base is. So just keep that in mind. You can say it does come with a drip pan, and you have some options here as well. But you can see here when I say it goes up a little higher, it goes up to 18,000 GPM. So this is our biggest offering that we have in our bailiwick. Even bigger than the KS and KBs. I know Rich has been involved with some projects where they specified some of these. So these are our bigger ones, 10-inch to 18-inch for the sizes, you know, the flange sizes. Inline pump, I mean, they do have the same horizontal entrance from that regard. You can see, you know, it goes up to 1,500 horse. I can only imagine how big that motor would be. I seen some 350s, I think, in the shop the other day, and they were humongous. So, you know, they are big bad boys as you go there. And then you have the working pressures that are available as well. So just another double suction type of series pump. A bigger one, you know, and obviously the cost is going up as you start specifying these. But you know, they do the job. They do the job. And again, we're not the only folks that offer these to the industry. There's other folks out there that offer them as well. And here's kind of the breakdown, material of construction. You know, it's very similar to the other to the TA models. There isn't a lot of differences here. You know, very normal type of seal, carbon, silicone carbide Viton. You get some options there, but nonetheless, you can see this type of seals. And again, it does come with a flush line. You know, it's a copper flush line, so that it just keeps those chambers flushing over that because they can heat up pretty quick or really get some issues there. And then you can see the working pressures and flange sizes on the right-hand side there. So you can get bigger type of flanges, similar to our similar to the base mounted pumps, the end suction pumps, right? I call them base mounted, but these are base mounted too. As you can see, there's a big base there for these pumps as well. So it's pretty. Most of the material of constructions for any of these pumps are very similar. There's not a lot of differences on there, and you can get some different options there if you'd like, but that's really based on your application. And your manufacturer's rep can get into more details of that, or maybe your office has some specifications for specific material of constructions anyways, and then our guys would have to make sure our sales folks, our manufacturers reps would have to make sure they meet your specifications. Here's another, I just wanted to show different types of cutaways. This one really explains the components, so you can get some ideas there. So you can see here's the shaft that would tie in and tie into the, you would think, to the impeller, but this goes over to the motor, right? Eventually through a coupler and whatnot, it goes over to the motor, because the impeller, this is the impeller right here. This is the impeller. You can see that these chambers feed into the impeller, so that's why it's a double suction. You can kind of see that there. There's a wear ring here. Just something. It's a wear part that you got to make sure it has some clearances there, or we do. There's that flush line I was talking about. Some sleeves on the shaft. Yeah, I think it showed you had different material of constructions you can have there. So you have a bearing unit down one end, right? That's capped on one end, and then there's a bearing on the other side as well. You got mechanical seals in there. Kind of just gives you an idea of the different components. It's always nice to at least know what the components are. It's pretty straightforward. I mean, in this picture, you can see it in our instruction sheets or online or whatever. So in case you ever want to, if somebody starts talking about something and you want to make sure you understand exactly where that component is, you can see that right here as well. And then there's that cover, right? And yeah, I like that statement. Easily removed, easily removed. Well, it sure is, right? It sure is. It's maybe it is easily removed, but pretty straightforward. And there's that shaft. And as you can see, because it's supported at both ends, in the impellers in the middle, that really it's not overhang, right? The end suctions have an overhang impeller, so it's a little different type of thrust and whatnot. So that's why for higher flow rates, I would really maybe tend to look at these in that regard. So at the beginning, I was talking about some of the differences, different types. Did I jump ahead? Okay, and this is our top TC. That stands for top connection. And so this is a vertical, right? So the split is
Hey,
along
Brett,
the vert.
before
Yep.
we get too far into the TCs, we did have a question that came up.
Okay.
Is the purpose of grouting bases to add weight?
To add weight?
That's the question. Yep.
No, the purpose to grouting bases is to make this component, make this whole unit one and the same as the pad that it's sitting on. Right, Rich? That's pretty much
Yes,
what it's
the
for.
purpose of grouting is to add stiffness so that it
Stiffness.
doesn't distort. If you're into automobiles at all, through the years, they make the body stiffer so that when you go down the road, the body doesn't flex and it's more stable on the highway, going around corners and stuff like that. So grouting adds stiffness to the base.
I, most, especially on the end suction pumps, it's in our TAs, it's critical that it's done. And there's many times out there, and I talk to contractors and folks on a regular basis. If once at startup, if there's an issue with a pump for vibration or noise or something like that, one of the first questions that's going to be asked, and as a matter of fact, it's in some people's instruction sheets. If you don't grout the base properly, you're avoiding the warranty. So it's one of the first questions asked if it's required to make sure you do it. That's I think we've got that question out there. Do you think so, Rich? Or answer, I hope.
Yeah, so someone did say the purpose of grouting is to add mass and stiffness, and we would agree with that. The moments and forces from the piping must be transmitted to the foundation. So that's a nice way of putting
Wow.
it. That was from
I'm
James.
going to have to make sure I read that one so I can put
Yeah,
that in
that's
my head.
yeah,
I like that. That's a great answer.
it is. I like that.
Yes. Yeah. Geez. So anyways, this is our top connection pump here. Pretty much similar, a lot of the similarities to the other ones, as you can see. Um, uh, Weld reinforced groutless base. So our literature says you don't have to grout this base. So put it down, set it properly, level it, align it. There's still alignment and setting and leveling and all that that's required. So something to consider as you go there. And I was when I got in today, it's a crazy story. I was going through my presentation and I noticed I had a mistake here, so I quickly changed it. But I figured I'd do it this way to show you my talent, right? Well, sort of talent. I guess it's not really talent, but you can see the performance data here. They don't go quite up to the ones the GTs, but they do get pretty big. So it depends on the application. There's some thought here that these pumps take up a little less room in the mechanical room. So something to consider there, maybe in regards to if you're looking at a inline pump, the KS pump, um, uh, and the piping associated with that, and maybe it's so something to think about. You'd have to do that your own little investigation there and see which way is a little better in that regard. You can see the piping goes straight up, right? So something to consider there. And again, they get pretty big. They get pretty big, up to 800 horsepower. They get big. That's all I can say. And you can see the different sizes there as we go. Well, one thing that's really critical, and if you do get a chance to look at the instruction sheets that you are able to download, is how you handle it, how these pumps are handled. It's very, very critical how you lift these. If you lift them incorrectly, bad things can happen. So especially, I mean, they get heavy, right? These things get really big and heavy. So it's really important that you gurney them the correct way in that regard. So if you look at the instruction sheet or someone does, it's something to consider. In order to look at it, you have to actually open it though. So I kind of get goofy sometimes. Again, standard material of construction. I think it might be identical to the screen I showed you for the to the GTs, TAs. So I'm not really going to spend a lot of time on it. Something to consider there. Then we have our TS, right? Our top side type of setup. So it's really just how you set up the inlet and the outlet. This is the inlet here. So the inlet's not up top. It's always on the side. But again, you can see that rotation is important, right? You got to tell us if you want it built this way or this way, right? So something to consider there. But nonetheless, you can see that standard drip pan. I apologize. The other one didn't. That's why I didn't call it out, but it does. Our product does come with a standard drip pan, but you can see you can get it. Depends on the orientation in the mechanical room, right? And it's really what's there. And this from a flow rate standpoint, it's the same. This screen is identical. I'm pretty sure. Maybe the head range might be off a little bit, but it's pretty much the same to the TC pumps. So another rugged construction. But people ask about applications, right? For these pumps compared to the other ones, and really it's a crossover, right? You got your chilled water, right? Big chilled water plants, condenser water plants, obviously heating, and everything else in between, heat pumps or whatever, ground source. These applications for bigger projects, people might tend to look at these, although we do see quite a few folks, because of the price difference and that vertical thought process in those KS pumps, look at the KSs instead. So there's an overlap there. It's really personal choice. There are still some specifications from some engineering firms where they specify a double suction pump to this day, right? They just have never changed. They've worked. They continue to specify them, and so be it. That's really their call. But for the most part, it's really an overlap. Rich and I get the question, well, which one should I use here? Which one should I use there? And it's really a team discussion. If you want us to get involved and get our opinions, or the manufacturer's rep's opinion, that's something to consider. Something else to think about. and I'm pretty sure this is for all manufacturers, these have a longer lead time than the base mounted, because the base mounted is the our bread and butter, so to speak. So that's something to think about as well in that regard. So things to consider as you start looking at a different process there. And again, this screen's the same. I do like to put it up there just so you realize that it's pretty much the same as all of the other ones. So I'm going to start talking about other things associated with Taco pumps. Any other questions, Rich? Or are we doing good now?
So at this point, we don't have any new questions, but this is
Excellent.
a good place to have folks add some questions if they have some out there before Brett gets into this next phase. I don't see any new questions popping up, Brett. So why don't we
Excellent.
continue? And if something comes up, I'll ask you to pause.
All right, my friend. So we've talked about this before, so I just wanted to at least, pat Taco on the back, pat us on the back. We're the only folks that have this setup, and this is our E-Link Taco connectivity. And there's these little chips. They're a little hard to see. They're right here, NFC tag for product info and support. So if I highlight them, you can kind of see, and they're on all of our commercial products. So they're on the TAs, GTs as well. And they're put on there, and they have a lot of information that you can get from your smartphone. A lot of information that you can get from your smartphone. And I'm going to just make sure everyone has gets to see that as we go here. But it's a near NFC tag for product info and support. What's that NFC? Near
field
frequency
communication.
That's it. Thank you. Thank you. And nowadays, most of us have a smartphone. So if you take your smartphone, have the Taco app, and put it on one of those, it's like you're taking a picture, right? It's like you have, like many of us has to do now when we go to a restaurant, right? Or we did there. Well, the pandemic's still going on, right? But in order to, they didn't have menus anymore. You had to scan your phone. Well, it's the same type of setup here. You scan this, and when you do that, it downloads here, and here's all the information you have access to: parts, submittal, instructions, catalog, specifications, right? So the first thing is what it is, right? It tells you the product profile. In this case, this is a tank, so it tells you all that, all the specifications. So if it was a pump, it's in essence tells you the nameplate, and that's what it tells you. And then the parts and documents, you can get a spare parts list for it as well as access to the parts. And all of Taco's parts, commercial parts, have 3D modeling, DXF, as well as the CAD drawings. So you have access to that as well. And then contact your sales rep. In this case, it was Hydronic Systems, but it could be any of the Taco sales reps. So that gives you a direct line to that. And then there's your CAD and Revit. You can get these emailed right to you of this product if you'd like. So a lot of information there. And then if you want, you can also contact Taco sales support as well. And if you call during normal business hours, a person actually answers the phone at Taco. Really? Wow, that's pretty impressive. But anyways, that's something to consider in that regard. So
We get real people, Brett, that answer the phone, but they don't take any food orders. We just want to clarify that.
Good point. Good
Good
point.
point.
Good point. And she does a great job as well. So nonetheless. So that's our E-Link connectivity, and again, it's on these pumps. It's on our products. We're very proud of it. It actually did win an award a few years ago now at ASHRAE for innovation under its category. So something to consider in that regard. So it's been out for at least 4 years now, maybe even longer. Well, we lost a whole year, so it has to be at least 4 years. And I'm saying we lost a year, but nonetheless, yeah, I got to digress for a second. A couple of weeks ago, we had a company appreciation picnic during working hours. They set up a nice tent outside our facility, and we're headquartered in Cranston, Rhode Island, and a lot of us got. Excuse me, I'm gonna take a sip of water. Got to show our appreciation to the folks that our frontline workers, and it was really a nice thing. We some of our manufacturers reps were there. We all stood up and clapped and cheered. Those folks, God bless them. They came in every day during the COVID crisis and produced products to help you folks, us folks, and kept the doors open. So God bless them. What they did and what they went through was phenomenal. So I'm going to kind of change focus a little bit, but it's still, here's some thoughts, basic rules of pump piping. I've showed this before, but let's hit it home again, right? Here's some 5 basic rules, and there could be 10, there could be 20, there could be 100, but nonetheless, here's some really important. And I tell you, those double suction pumps, some of these rules are even more important for those. They're always important, but keep suction piping as short as possible, right? Don't have it that long. You can read these here, and then that diameter of pipe from the suction should be equal to or greater than the pump inlet, right? So you don't want to cut, if it has a 6-inch pump inlet, don't bring a 4-inch and go up to 6. Something to make sure you do that. You want to be 6 or greater coming down into it. And try to eliminate as many elbows on or close to the inlet nozzle of the pump, right? And then you got that old 5 to 10 pipe diameters, or maybe a suction diffuser instead. And I'll show you a picture shortly about what we're talking about there. That's another pump, a product that you can get from your manufacturer's rep, and we all sell them. And that really it allows you to not have to use that 5 to 10 pipe diameters to get the good flow going into the pump. And then on these double suction pumps, you got to watch the orientation of the elbows. And I'll show you what I'm talking about that very shortly. But you need the flow, equal flow, to get on both sides of that impeller, top and bottom. If it doesn't do that, you're going to wear things out or cause other issues very, very quickly. And then eliminate air pockets, right? The ups and downs in piping, eliminate that. Get rid of that. Don't do that. Don't eliminate air pockets. And then and pipe away from pumps. Don't pipe to pumps, right? So you don't want to put strain on the pump casing. That can knock things out of alignment. You'll have to remount things to the base, or try to realign the motor and the coupling. So really support the piping. And pipe away in that regard. And this is what I was talking about, right? So it depends on which way you're going. You got a concentric elbow, reducer here. So you want the, if it's coming from, let's see, it's going to put the flat on top when fluid is coming from below or straight. So if the water's coming this way or straight in, you want the flat on top. And this was here, that gets you a nice flow going into here. If it's coming down, this is probably the more common one, right? Coming down from the top, you want this on the bottom here. So that will avoid an air pocket at the pump suction and allow air to be evacuated. You can see that there. Some ideas here. This is in our instruction sheets. Some piping thought processes there. It's very, very important for these types of pumps we're talking about today. Here's why you want to have that 5 to 10 pipe diameters, or use a suction diffuser, okay? So this one has a suction diffuser, this one doesn't. And what happens is, if you can get the incorrect flow, see how it jumps up here, you're getting more high flow, higher pressure, and this is low flow, and this could cause cavitation and could cause all kinds of issues. Maybe the bearing might fail a lot quicker or whatever. So you want to be able to have nice uniform flow coming in here, so you get the equal amounts going to both sides. So very, very critical, very, very important. And you could do that with that trim, that piece of trim we're talking about, that suction diffuser. So something to consider. Here's just one picture. On the left is a good do, and the right is a don't, maybe. And see how uniform this is, straight up. There's no forces on this. This is nice and clean. If you look close here, can I zoom in on this? You can see how this coupling flex is strained, right? So this could cause some issues. You could see stresses are being put on that pump, and something could be happening in that regard. So that is just something you got to look out for and try not to allow to happen as you go through it. So some things to consider there. Pressure gauges, you can kind of see it on this one here. They're over here as well in different locations, but nonetheless, there are tappings there. Put pressure gauges on pumps, especially on the discharge side. If there's gonna be issues and you start calling people or you go to the job site, I'm sure most of the details that you have in your pump packages, MEP drawings, show pressure gauges. But man, if they don't, put them in there. Definitely on the discharge. If you can also get one on the suction side, I know maybe it gets out, it costs too much, blah blah blah. But really, that differential is proportional to the total head for the pump. It's a lot easier to diagnose problems when that has. Rich has a funny story about pressure gauges. There was two on a job one time, and one wasn't working correct or was zero, and they thought there was a problem with the pump. He says, well, take the one that's working and put it where the one that's not working is, and take the other one and flip it around. And what it was the pressure gauge was bad, but nonetheless, put them on there, put them in your details. Some of this goes without saying, but we need to say it anyways as we can. Flow
So Brett,
control.
here's another little tip
Yeah.
when it comes to pressure gauges, especially in an open system like for a condenser water system that has a cooling tower. We actually experienced this just the other day. So I asked for readings. I said, well, what's the inlet pressure on the pump? It was a condenser water pump. And they said, well, it's 0. And I said, well, I've done
That's
some
good.
calculations. It's probably less than 0. I think the gauge is pegged. So can you replace the gauge with a compound gauge that reads both positive pressure and either negative pressure or inches of mercury? And sure enough, they put the compound gauge on. It was reading 20 inches of mercury on the negative side. So my recommendation is that if it's a condenser water system, not only put a gauge on the suction side, but make sure it's a compound gauge.
Aha. Another tidbit. Rich's tidbit. I'm going to add that to my presentation. Rich's tidbit that he's come across over his illustrious career.
Yeah, and actually, this came up only a week or so ago, Brett. And it turned out that there was nothing wrong with the pump. It's that they had a too high a pressure drop on the suction piping, and that created the negative pressure at the inlet of the pump. And as soon as they put the compound gauge on, they realized that the pump was in fact doing the pressure differential, but the pressure was so low on the suction side of the pump, it was starting to cause the pump to cavitate. So that it was an important little tidbit, like you said, tidbits.
Yeah. It's kind of amazing over time how many tidbits that there's probably thousands of tidbits out there from the discussions we had.
They should make crackers and call them tidbits. Does anybody make crackers called tidbits? I don't know.
I don't think so. That's a good name though. Flow control. Put it on the discharge. If you're going to use a valve for flow control, put it on the discharge of the pump. Never use a flow control valve on the suction side for this purpose. Obviously, you got shut off valves, but put it on the suction side. Obviously, you can. Another way is VFD, and that's probably it should be up top, right? Nowadays, the VFDs, I think it's 5 horse and greater has to have one, but nonetheless. But you can also trim impellers, right? So that's something to consider if you get into a bind. For whatever reason, you got to look at that impeller size and start thinking about whether you want to trim it or not, or make, if you can, based on horsepower. We're not talking about curves or that much. We've done that in other presentations, right? If it's the right horsepower, you can increase the impeller size to get some more oomph there without adjusting too much else on the project. So different ways you can control flow. But I think nowadays VFDs are the way to go, or they are as well. Some ideas about suction valves. You know, there's different types, right? Just like that tidbit Rich said about the pressure gauge. You know, maybe a gate valve is the best one as used, because it doesn't add any resistance, or very little resistance on there, and it can provide a tight shutoff, right? So you know, the less resistance we can put on a pump, maybe it helps the head loss, right? That you're talking about once you start doing your calculations. Many times butterflies are used, but they do provide some resistance there, and you have to take that into account. I'm not saying it's a big deal, but nonetheless, it's something to consider about. And then, you know, potentially you get some hangups, which you know, that's not good, right? Hangups on the suction side is not good at all. So I think I'm winding down, Rich. I might be winding down, and I just want to reiterate, you know, these pumps, any of the pumps that we've talked about that we supply, work most efficiently when the fluid is delivered as a surge-free, smooth laminar flow, right? So make sure the piping's correct, make sure it's installed correctly, and I'm telling you, these guys can last. These things can last a very long time if they're installed correctly. I was reading a couple of ASHRAE journal reports about you know, how long does an HVAC system last, or how to get rid of it over time. I forget the exact title. You know, in this 20 years, I'm telling you, these pumps, they should be able to outlast most of the equipment on these if they're installed correctly and have a good setup, and you know, a little bit of maintenance, obviously, over time, but nonetheless, any way you can help that as you go out there in your careers, installation, specifying whatever, that they should be able to work. Because as much as you like talking to your manufacturer's rep and Takeo and Rich and Brett, you don't want to when there's an issue. And we don't want to as well, because to be quite honest, and this is a top secret, right, Rich? This is top secret. Of all the calls we get, because there's a problem with the pump, 80 to 90% of them aren't a problem with the pump. Correct, Rich?
Yeah, that's correct. The overwhelming majority of issues that we are asked to sort through, because initially it's thought to be the pump. It turns out it's not the pump, but it happens to be some type of system configuration. And like I said, I'm going through this right now on a project. The pumps were installed 10 years ago, and the piping is not optimal, and so they're experiencing negative pressure on the suction side of the pump.
So it could always take a minute or two, but whatever, you know. And thank God everyone's saying you're at the end of the presentation. Questions? Any other questions? It's getting close to 1 o'clock. We're here till whenever, but you know, when you get into these presentations and we're deep diving into products, it's not system related that much. Maybe there aren't that many questions, but hopefully, like I said, I'm going to go back to that one screen that I want you to take away. Where is it? Where is it? I'm getting there. Make sure this is correct when you order these pumps or you get involved with a project with one of these, the clockwise or counterclockwise rotation.
Yeah, and if there's any
it's critical.
confusion, we see where it says clockwise rotation viewed from the coupling end. You can think of the electric motor, in this case, as the coupling end. Just think of yourself as sitting on the electric motor, and then you're looking toward the pump, and that's the orientation that you should be looking at.
That's not the guy's nose. That's his eyes looking this way.
That's his eyes. He's got like Superman X-ray
yeah,
vision.
he's got small eyes, but nonetheless, sit on the motor and look that way. But to think about it, when you're in a mechanic, you know, when you got your design and you got your piping layouts and your base, your pad, and how the pump's going to sit on there, just pretend you're sitting on that
Just
motor.
as a quick safety thing, please never sit on the motor when it's running. Never sit on the motor. That's really just for as if you were, use your imagination as if you were sitting on. But
yeah, there you go.
Yeah,
too funny.
I'll get a call from OSHA this week, Brett, and they'll say, "Oh, you guys said to sit on the motor." No.
Yes, it's a
as
good
if
point.
you were sitting on the motor.
Yes. I'm going to erase it right now because I don't want anyone to sit on that motor.
Yeah.
Oh, this one's not operating, so we're in good shape.
Yeah, that one appears not to be connected. So listen, Brett, we're just about at 1 o'clock, and I'm going to ask for any last minute questions. Any last minute questions out there? It doesn't look like someone's going to ask any questions. I've got a couple of thank yous so far. So at this point, Brett, I'm going to say we're pretty much wrapped up for this presentation today. And again, look for your recording. Will be available roughly 24 hours from now. And also, if you're interested in the certificate, look for the email notification roughly 24 hours from now. So I think we're all set. Brett, do you have any last minute things you want to say? If not, we're going to sign off here in a few
I
seconds.
just want to say thanks for everyone's time. We know how valuable that is. We appreciate it. And we'll see you in a couple of weeks. We got to get our act together, Rich and I, to figure out what we're going to be talking about down the road. You know, I've said this before, our manufacturers reps that we have are the best in the industry. Contact your local one. You can find out who it is. If you don't know, right on our website, it has a find local rep, and they can answer even more questions about these bad boy pumps. So signing off, Rich, take it away.
Thanks a lot, Brett. Great presentation. And thanks so much, everyone out there in the audience, for participating in Taco Tuesday. Signing off. Take care now.
Bye, everybody.